Hello grade 10 students. Welcome to another virtual class. I am Ms. Madhu Vadke. We are studying chapter 14 Statistics. And we are learning how to calculate measures of central tendency of a data. These are also called as mean, median and mode. So far in the chapter we have learned formulas to find mean and mode of a grouped data. In today's video lesson, we will learn how to find the median of a grouped data. So let's start by recalling the definition of median that we have studied in lower classes and the formula to find median of an ungrouped data. Median is a measure of central tendency, which is the value of middlemost observation in the data. So let's say x1, x2, x3 and xn are the observations for which we have to find median. Then the first step is to arrange this data in ascending order. Here n stands for the number of observation. So if n is odd, for example there are 9 observations, then the median is given by n plus 1 upon 2th observation. And if n is even, for example there are 10 observations, then in that case median of that data is given by the mean of or average of n upon 2th observation and n upon 2 plus 1th observation. This is same as n upon 2th observation plus n upon 2 plus 1th observation. Their sum divided by 2. This is what we have studied in grade 9 for finding the median of an ungrouped data. Now this value of median may or may not be one of the numbers from the observation. What median does is divides the data into two equal parts. One part has values smaller than the median and the other part has values greater than the median. Now the same method cannot be applied to find the median of grouped data, because a grouped data has observations in terms of class intervals. So the method of finding median for a grouped data is entirely different. So now we will understand how to find median of a grouped data. The first step is to calculate cumulative frequencies. So let's understand what are cumulative frequencies. To understand cumulative frequency, let's consider an example which is given in this table. This is a grouped frequency distribution of marks obtained out of 100 by 53 students in a certain examination. Looking at the table, we can answer how many students obtain marks less than 10. The answer is 5. Students who obtain marks from 10 to 20 are 3. But if I ask you how many students obtained marks less than 20, then the students who obtain marks less than 10 will also be included in that answer. So students who obtain marks less than 20 will lie in the class interval 10 to 20 and 0 to 10 both. So the answer will be 8. Likewise, students who obtained marks in the class interval 20 to 30 are 4. But students who obtained marks less than 30 will include the class interval 0 to 10, 10 to 20 also. So the answer will be 5 plus 3 plus 4. So students who obtain less than 10 will be 5, students who obtain less than 20 is 8, students who obtain less than 30 is 12. These numbers are called as cumulative frequencies. So the same table can be written in this manner. Likewise, we can find cumulative frequency for all class intervals. And notice that students who will obtain less than 100 should be equal to the total number of students giving that test, because less than 100 includes all class intervals of that data. So the last number over here is n, that is total number of observations or the sum of frequencies. This distribution is called as cumulative frequency distribution of less than type. Notice that these numbers 10, 20, 30, 40 and so on are the upper class limits. So in this distribution we are writing less than upper class limit. In the same manner we can write the cumulative frequency distribution of more than type. But we are going to skip this part as the formula for median given in the chapter is based only on less than cumulative frequencies. More than cumulative frequencies are required to draw ogives, which is deleted from the portion this year. However, those who are curious can study this part from the textbook. So in order to find median of a group data, the first step is to calculate the cumulative frequency of the class intervals. Now from the definition of median, we know that median is the value of middlemost observation in the data. By looking at the cumulative frequencies, we may not be able to find the middlemost observation, as it will be lying somewhere in the class interval. However, we can find out in which class interval this observation will be lying. This class interval is called as median class. So let's learn how to identify this class interval in which the median lies, and then we are going to learn a formula to calculate this median. So the first step to find the median is to calculate the cumulative frequencies of all the classes. The next step is to find n upon 2 and locate the class whose cumulative frequency is greater than and nearest to n upon 2. This class interval is called as median class. What does n denote here? It is the total of the frequencies or total number of observations. Once we have located the median class, then we can use the formula to find the median, which is given by L plus in brackets n upon 2 minus Cf divided by F multiplied by H. Here L stands for the lower limit of the median class, n upon 2 stands for half the total number of observations, Cf is the cumulative frequency of class preceding the median class, F is the frequency of the median class, and H is the class size, assuming all class sizes to be equal. There are methods to find median for unequal class sizes, but it is not included in 10th standard portion. So keeping in mind these steps that we have to follow, let's apply this formula to find median in exercise 14.3. Question number 1. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean, and mode of the data and compare them. First, we will find median for this data. So for that, we will have to draw one more column. in which we are going to write down the cumulative frequencies represented by CF. And the monthly consumption is the data which is given as class intervals. So we are going to write down less than cumulative frequencies for this data. So number of consumers less than 85 will be 4. We copy the same frequency as cumulative frequency for the first class interval. For the second class interval, we have to find cumulative frequency for less than 105 units. That means number of consumers having consumption less than 105 units. So that will be 4 plus 5 equal to 9. Likewise, cumulative frequency for the next class interval will be 4 plus 5 plus 13, and that is equal to 22. Next number will be 42, 56, 64 and 68. The total number of consumers are given as 68, and the last number of the cumulative frequency should also be 68, because the last cumulative frequency stands for the total of frequencies, which is total number of observations. So we can write down n over here is 68. So n upon 2 will be 34. The second step is to find the median class. Median class is the one whose cumulative frequency is greater than and nearest to n upon 2. So we have calculated n upon 2, which is 34. Now we have to look in the column of cumulative frequency and find the cumulative frequency which is greater than 34 but nearest to 34. So that is 42. So the median class is 125 to 145. So the median for this data will lie in this class interval, which means your final answer should be between 125 to 145. So from here we can write down L, that is the lower limit of median class. It is equal to 125. CF is the cumulative frequency of the class preceding the median class. So that will be 22. And F is the frequency of the median class. So that will be 20. The class size H is upper limit minus lower limit, and that is equal to 20. So now we have all the data to use in the formula. Let's apply the formula to find the median. Make sure to write down these formulas every time you use them, because they help you in memorizing. Now substituting these values, we get 125 plus 34 minus 22 divided by 20 multiplied by 20. Now here the numbers are very easy to calculate. 20 and 20 gets cancelled, and we get 125 plus 34 minus 22 is 12. So this sum gives us 137 units. So the median value is 137 units. That means this is the value that divides the data into two equal halves, such that one half has consumption of electricity less than 37 units and the other half has consumption more than 137 units. And this number 137 lies between 125 and 145. Now we also have to find the mean and mode and then compare these three numbers. Let's find the mean of this data. To find the mean using assumed mean method, we need 5 columns. In the first column, we have to write down the class intervals. In the next column, we are going to write down class marks. The third column is number of consumers, which is the frequencies Fi. In the fourth column, we will calculate the deviations, which is xi minus a, and in the last column, we will find out the product fi di. For the first class interval, the class mark will be 85 plus 65 divided by 2, so that is 75. And since these class intervals are of equal size and the class size is 20, the next class mark can be obtained by adding 20 to 75. So next class mark is 95, 115, 135, 155, 175 and 195. Out of these class marks, we will choose one class mark as the assumed mean. So let's say 135 is the assumed mean. For each class interval, now we will find di. So di for the first class interval is 75 minus 135, which is minus 60. The next will be minus 40, minus 20, 0, 20, 40 and then 60. Now find the products fi di. So we get minus 240, minus 200, minus 260, 0, 280, 320 and 240. We can cancel minus 240 and 240 because we have to now find the sum of fi and di values. So summation fi di is equal to 140 and summation fi is 68. So substituting these values in the formula of mean, a plus summation fi di divided by summation fi, we get 135 plus 140 divided by 68, which is equal to 135 plus 2.058, that is equal to 137.06 units. Now let's find mode for the same data. So the first step is to identify the modal class. Modal class is the one that has highest frequency. So looking at the frequency column, we find that 20 is the highest frequency and corresponding to it 125 to 145 is the modal class. So frequency of class preceding the modal class will be f0. Frequency of modal class will be f1. Frequency of class succeeding the modal class is f2. So the lower limit is 125. Class size h is 145 minus 125, that is equal to 20. And we have all other values that needs to be substituted in the formula of mode. So let's calculate mode. This is 125 plus 20 minus 13 divided by 40 minus 13 minus 14 into 20. So we get 125 plus 7 into 20 divided by 13, that is equal to 125 plus 10.76, which is equal to 135.76 units. So these are the values of median, mean and mode for the same data, and we find that they are not same. Mean is greater than median, which is greater than mode. Also, there is a relationship between these three values of measure of central tendency, which is given by 3 times median equal to mode plus 2 times mean. On substituting above values of median, mean and mode in this equation, you will find that the left hand side is approximately equal to the right hand side. This is because this equation is an approximate relationship between the three measures of central tendency. In fact, mean, median and mode are approximate values given that they are calculated for very large data. However, we can use this equation to find any one unknown value of measure of central tendency when the other two are known. Let us now understand which measure of central tendency is best suited for a particular situation. The most frequently used measure of central tendency is mean. The reason is that mean takes into account all the observations and lies between the extremes, that is, the largest and the smallest observation of the entire data. It also helps us to compare two or more distributions. A simple example is if you want to compare the performance of 3 classes in a test, then the average marks obtained by each class will help us compare the result and conclude which class has a better performance. However, extreme values in the observations affect the mean value. For example, if we have a data in which one class interval has a very small frequency compared to other class intervals which have frequencies which are 2-digit or 3-digit numbers, then mean will not represent the data correctly. So in such cases, mean is not a good representative. If we have a data in which the individual observations are not important, then finding median is more appropriate. For example, average wages in a country where there may be extreme values, then in that case, median will be a better measure of central tendency. Another example could be, let's say we have a group of people which are to be divided into 2 teams. One group with smaller height and another group with greater height, so that these 2 teams can be allotted games accordingly. So in this case, we will collect the data of their heights and then find the median. So the median will divide this group, that is the heights, into 2 parts, so that one part has heights smaller than the median and other part has heights greater than the median. So clearly the individual heights are not important here. What is important is the middle value. In other real life situations where we need to find the most frequent value, for example, the most popular game or a consumer item that has greatest demand, or a product that is liked most by the people. So in such cases, we represent the data by finding its mode. Now let's solve some different type of questions by applying the formula of median. Question number 2, if the median of the distribution given below is 28.5, then find values of x and y. To find the value of x and y in this question, we proceed in the same manner, that is, we use the formula to find out median. So let's draw one more column so that we can write down cumulative frequencies. Since we are finding less than cumulative frequency, so we copy the first frequency as cumulative frequency for 0 to 10. So the first cumulative frequency will be 5. Cumulative frequency for less than 20 will be 5 plus x. Similarly, 5 plus x plus 20 will be the next cumulative frequency, so that is 25 plus x, then 40 plus x, 40 plus x plus y, and the last cumulative frequency will be 45 plus x plus y. The total number of frequency is given as 60. So n is equal to 60. So we have 45 plus x plus y equal to 60. We know that the last cumulative frequency in the table gives us the total of the frequency. So we can equate it to 60. Solving this equation, we get x plus y equal to 15. Mark this equation as 1. Now we are given the median of this distribution, which is 28.5, and 28.5 lies between 20 and 30. So the median class is 20 to 30, and now we can mark CF and F. CF is the cumulative frequency of the class preceding median class. So this will be the cumulative frequency, that is 5 plus x, and F will be the frequency of the median class. So 20 will be F. The class size H is clearly 10. So now we can use the formula for median. So median is equal to L plus n upon 2 minus cumulative frequency divided by F into H. Substituting these values in the formula, on the left hand side we have 28.5 equal to, on the right hand side, 20 plus in brackets 30 minus 5 plus x. Now write 5 plus x in the bracket because there is a minus sign before it. Whole divided by f, which is 20, multiplied by h, which is 10. So we can cancel the zeros over here. Carry 20 to the left side. So we get 28.5 minus 20 equal to 30 minus 5 minus x divided by 2. This is 8.5 equal to 25 minus x divided by 2. So 17 is equal to 25 minus x. This implies x is equal to 25 minus 17, and that is equal to 8. Using this result, which we have marked as 1, we have x plus y equal to 15. So substituting value of x in this equation, y will be equal to 7. So the values of missing frequencies x and y is 8 and 7 respectively. Question number 3. A life insurance agent found the following data for distribution of ages of 100 policy holders. Calculate the median age if the policies are given only to persons having age 18 years onwards but less than 60 years. Notice the table given in the question. We are given age in years, below 20 years, below 25 years, and so on. In the second column, we are given number of policy holders. These are the cumulative frequencies. Notice that the total number of observations is 100 over here, and the last cumulative frequency number is 100. So in order to use the formula for median, we will have to find the frequency from cumulative frequency and also the class interval. So in the first column we have age in years, which is written as less than the upper limit of the class interval. So 20 is the upper limit, 25 is the upper limit. Observing these upper limits, you will be able to understand that the class size of these class intervals is 5. So we can write down the class intervals as 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55 and 55 to 60. Now from the given values of cumulative frequencies, we will calculate frequencies. So for the first class interval, that is 15 to 20, the frequency will be same as the cumulative frequency, that is 2. For the next class interval 20 to 25, the cumulative frequency 6 includes the frequency of the previous class interval. So we need to subtract the frequency of the previous class interval. So 6 minus 2 is 4. Likewise, the cumulative frequency of the third class interval includes the frequencies of all the previous class intervals. So we have to subtract 6 from 24 to get the next frequency, that is equal to 18. Likewise, we can obtain frequency for all class intervals. The next one will be 45 minus 24, which is 21. The next will be 33, 11, 3, 6 and 2. You can also total these frequencies and check if you have calculated these values correctly. The total should be 100. If it is not 100, then there is some error. And you can go back and recheck. This data contains 100 policies. So this implies that the number of observations are 100. So n is equal to 100. That means n upon 2 is 50. So now we can find the median class by looking at the cumulative frequency column. Find the cumulative frequency that is greater than n upon 2, that is 50, that is greater than 50 and nearest to it. So the cumulative frequency which is greater than 50 and closer to it is 78. So the median class is 35 to 40. So L from this data will be 35, that is the lower limit of the median class. CF is the cumulative frequency of the class preceding the median class. So this implies CF will be 45 and F is the frequency of the median class. So 33 will be F. The class size is 5. So using the formula L plus n upon 2 minus cumulative frequency in brackets divided by F into H. Substituting these values, we get 35 plus 50 minus 45 divided by 33 into 5, which is equal to 35 plus 25 divided by 33. Converting 25 on 33 into decimal, we get 0.76. So the median value is 35.76 years. Question number 4. The length of 40 leaves of a plant are measured correct to the nearest millimeter, and the data obtained is represented in the following table. So we have length of leaves in millimeter represented in groups as class intervals, and the number of leaves are the frequencies. Observe that these class intervals are non-continuous. Since we need to substitute class size in the formula, we need to make these class intervals continuous. To make these class intervals continuous, you will subtract 0.5 from the lower limit and add 0.5 to the upper limit. So I'm going to write the converted class intervals next to these intervals over here. I've added a new column. This column is for cumulative frequencies. So the continuous class intervals will be 117.5 to 126.5, 126.5 to 135.5, and so on. Next, we will find the cumulative frequencies. Since we are finding less than cumulative frequency, the first cumulative frequency will be same as the frequency. So the first number is 3. The next number is obtained by adding 3 to 5, that is 8. The next number is obtained by adding 8 to 9, so we get 17. Then 29, 34, 38 and 40. The last number should be same as the total number of leaves that are given in the question. So n is equal to 40, therefore n upon 2 is equal to 20. Now look at the cumulative frequency column and find the cumulative frequency that is greater than 20 and nearest to it. So that value is 29. The class interval corresponding to this value is the median class. So the median class is 144.5 to 153.5, and therefore L is 144.5. The class size h is obtained by subtracting the lower limit from the upper limit of continuous class intervals. So 126.5 minus 117.5 is 9. CF is the cumulative frequency of the class preceding the median class. So 17 is CF and F is the frequency of the median class, so that is 12. Now substituting these values in the formula of median, we get 144.5 plus 20 minus 17 divided by 12 into 9. So this is equal to 144.5 plus 3 upon 12 into 9. Nine upon 4 in decimal is 2.25. So adding these two numbers, we get 146.75 millimeters. So this is the median length of the leaves. With this, we come to the end of this video lesson. Your assignment for today are these questions from exercise 14.1. Question number 5, question number 6 and 7. See you in the next class. Until then, goodbye.